Hi, my name is Lucky Obwefi, and this is my Lab 3 for Physics 2212 covering circuits. So for some overview for what this lab is about, the objective of this lab is to determine essentially the effect of resistors and capacitors across an RC and a DC circuit. We will look at how these resistors affect current, voltage, and resistance measured in ohms. And there are going to be some key assumptions to make this model work. For example, negligible resistance in the wires themselves, as well as the ammeters that will be measuring the current in the wires. We will have to assume they carry no resistance themselves, where obviously in real life, these ideal conditions would not be what we see. We'll compare these experimental data to some of the theoretical predictions that we should have observed due to things like Ohm's law and the loop rule. So for some more overview, as you can see on the right, there are two depictions of the two sort of smaller experiments conducted inside the lab. Again, one of them is going to be that RC circuit and the other being the DC one. RC being that there is a resistor and a capacitor present. So again, there's an RC type, which includes the capacitor and resistor, and the other model includes the battery, the EMF, two resistors, and the two ammeters. The node rule, as well as the rules, were upheld from the observations, and this is just a preliminary kind of look at the results that we did get. Again, there will be deviations, but we'll discuss kind of the error from that later. To touch on those physical principles, the first one is going to be Ohm's law, and this just says that the voltage is equal to the current times the resistance, where V is voltage, I is current, R is resistance. Then we have the loop rule, which says that the voltage in any circuit element is the sum of the independent voltages in each kind of part of the circuit. In an ideal, well, in the real world, this will always add up to zero because the voltage is conserved throughout, and this really is the basis for path independence that we see. Lastly is the node rule, and this is just saying that the current into any circuit element is the current out of the element, and that kind of gets into junction rule, but for this lab we are not looking at that. So on the right you can kind of see our setup in the actual lab. It's a little cluttered, but it does create that circuit that we had depicted on the previous slide. The protocol from the laboratory was followed in such a way that the batteries were arranged in a series, so therefore their voltages add, or at least their potential add, which would make 1.5 times 2, which is equal to 3. This is the same for the resistors. The effect on the voltage was analyzed using those two emitters that you can see. The system will include the circuit and its circuit elements, where the surroundings will be everything else. So for an analysis of the DC circuit, with some math that we ran, the current was measured to be about 0.024 amps. The change in the potential across the entire thing was about negative 2.8 volts, which is not ideal, but we'll get into that. There was a negative 1.9 change for the 100 ohm resistor, and a negative 0.9 change for the 47 ohm resistor. Experimentally, the delta V was about 0.1 or 0.2, where it should have been 0 in real life, but we'll get into why that is the case and why that wasn't observed later. Now for the RC circuit, for the 10 ohm resistor, a 14.3 second charge time and about a 17-second discharge time was observed. And for the 20 ohm resistor, a 57-second charge time and a 50-second discharge time was observed. With the voltmeter attached, the ammeter reading is unchanged because it has such a high resistance where essentially no current is passing through it. So it's going to measure the same voltage each time. So now for the results, it was pretty clear that theoretical reasoning, at least when it comes to the loop, to the loop itself, node rule and Ohm's law, they were in fact observed with some deviation. The voltage did, for the most part, match expected results and satisfied some of the physics principles that we do know to be true. There was a little deviation in the form of that charge difference that was about 0.1 to 0.2 at the end, but we can kind of sum this up to being attributed to, obviously there is going to be some resistance in those wires as well as the ammeter, because this is the real world. So, and there's also going to be some human error elements in, incurring charge. And there's also going to be errors in timing that may have played a role that weren't exactly accurate. But all of these kind of contribute to why that total potential change wasn't exactly 0 by the end of our measurements. So lastly, for the discussion, if a battery was used without the presence of any resistors, then essentially the capacitor would charge essentially instantly. The resistor slows down the current, and obviously this will change how fast the capacitor is charged. So without its presence, there would essentially be no slowing, and it would charge at the speed of light, which to us might as well be instantaneously. Thank you for watching.